Hi. So this is a classic related rates problem. You have one bicyclist traveling this way. It doesn't tell you which directions, but they're perpendicular. So, and you have another one traveling this way at 16 kilometers per hour. So what you ultimately are tasked with finding out is this, right? We want to know the rate at which the distance between them is changing. Okay, so if you think about what kind of formula we're going to need for this, it's going to involve a formula for right triangles. So we'll get there in a second. So we need to fill in some gaps in this right triangle. We know that bicyclist A has gone 12 kilometers per hour for 1/2 hour. Still getting used to this pen. So that's 6 kilometers. Pretty easy math. Okay, similarly, you know that the other bicyclist has gone 16 kilometers an hour for half an hour. So he's gone 8 kilometers. So we can label that. So person A has gone 6 kilometers, person B has gone 8 kilometers. Okay, so now like with any related rates problem, we need a formula. So once again, we are interested in information about this, the distance between them. And in the language of math, that would be called the hypotenuse of this right triangle. So you know that this squared plus this squared equals this squared, right? So that's just the Pythagorean theorem. Okay, so let's call this x, y, and let's call this z. So x is the distance the first bicyclist has gone, y is the distance the second bicyclist has gone, and z is the distance between them. Okay, now x, y, and z are all functions of time. So that's where you get to do this fun implicit differentiation, right? X is a function of time, y is a function of time, and z is a function of time. So they're all changing. That's why it's a related rate. That's why it's a calculus problem. So you do the thing where you do the derivative of both sides, and you treat x, y, and z all like they're functions, like they're functions of some variable t, which they are. So when you do the variable of x squared, you know that involves the chain rule. So it's actually 2 times x. And then the chain rule says it's times whatever the derivative of x is. So rather than write dx dt, I'm just going to write it as x prime because I've always thought that was cleaner. Okay, so they're all functions of time, t, but we don't really need to indicate that. We can just say, okay, it's x prime, which is the rate at which x is changing, which this will come in handy later, we know is 12. Okay, so same deal. The derivative of y squared is 2 times y by the power rule, and then times the derivative of y, which I'm just calling y prime, and then exactly the same thing with z. Okay, so that's our setup. Now we kind of need to say, wait, what were we even asked? We were asked for the distance at which, the rate at which the distance between them is changing. So the distance between them is z, right? And the rate at which z is changing is z prime. So now we get to do some algebra. And you have to solve that equation for z prime, which is not the hard part. So to solve that equation for z prime, so don't plug in any numbers yet. I was kind of warning against that. So to solve that equation for z prime, you just divide everything by 2z. So we're going to have z prime equals 2x prime plus 2y prime all over 2z. And I'm going to come over here. So all we can really do is divide everything by 2. Why not? So we have x prime plus y prime over z. All right, and now believe it or not, we know everything. We know all of this stuff. So x prime, also known as dx dt or x prime of t, is the rate at which x is changing over time. X is the distance the first bicyclist has traveled. So the rate at which he or she has traveled over time is known. It's 12. Right? So let me make a little note of all the stuff we already know. We know that, well, let's see. We know that x is 6 because that's just the distance. And x prime is 12. let's not worry about units yet. All right, we know that y is 8 and y prime is 16 because that's a rate. And, we don't know z, but can we get it? Yeah, so to get z, we just have to do a little bit of Pythagorean theorem up here. 6 squared plus 8 squared is z squared. Sure, you can handle that algebra. That's just, 6 squared plus 8 squared is actually 100. So z is 10. Okay, so you see what I mean? We have everything we need to fill in this side of the equation. So x is 6, x prime, look at use this pen, is 12, plus y is 8, y prime is 16, z is 10. No shame in using a calculator for this next part, so it's going to be 6 times 12 plus 8 times 16, which is 200, divided by 10 is 20. And for units, remember, it's the rate at which the distance between them is changing, so it's kilometers per